morning, ladies and gentlemen. Welcome all to the next UNESCO Chair seminar organized by UNESCO Chair on Ethical Governance of Artificial Intelligence in our Institute of Fundamental Technological Research of Polish Academy of Sciences. Today's meeting is devoted to a very interesting and current topic in the field of generative artificial intelligence. The title of the lecture, PLLuM, Polish Large Language Model, will be delivered by Prof.Maciej Ogrodniczuk. Welcome, Professor Ogrodniczuk. Professor Ogrodniczuk is the head of linguistic engineering group in Department of Artificial Intelligence in Instytut of Computer Science in Polish Instytut Podstawowych Informatyki Polskiej Akademii Nauk. He will present the Polish large language models, the need for the existence of such a Polish system, we can say maybe Polish ChatGPT, is indisputable, so we will listen to the lecture with great interest. Professor Ogrodniczuk, the floor is yours.
Yes, thank you. Thank you for the great introduction, and thank you for inviting me here. My name is Maciej Ogrodniczuk. I'm the head of the language modeling department at the Institute of Computer Science. That's the institute with the logo in the middle of the set on the slide. And I will be talking about PLLuM. Let's pronounce it PLLuM and not plum, although there are some fruity connotations, about the Polish large language model. Just as the professor said, it's not one model, but a family of models, and you will find out in a moment how we created it and how we deployed it in public administration. So I'm reusing the slides of many people. Some of them are mentioned here with two honorable mentions of Maciej Piasecki from Wrocław University of Science and Technology, who led the first part of the project, Agnieszka Karlińska, who led the second part. So I'm not just talking for myself and my institute, but for the whole consortium of these great eight institutions that were involved in development of PLLuM. So what is PLLuM? PLLuM is a project. Let's start with it. It's a project that was running for 2 years in 2024 and 2025. First, it was called PLLuM and was led by Wrocław University of Science and Technology in a consortium of 6 research institutions: NASK Research Institute, National Information Processing Institute, Wrocław University of Science and Technology, our Institute of Computer Science of Polish Academy of Sciences, University of Łódź, and the Institute of Slavic Studies. So there were 2 institutes of the Polish Academy of Sciences, 2 universities, and 2 national research institutes. In 2025, after a year of running the project and development of the first models, the project was renamed to HIVE, and 2 more institutions joined. They were Center for Information Technology and Cyfronet, which is the academic computer center of the AGH University of Science and Technology in Krakow. So there were many institutions, many people involved. There were about 200 people involved in development of this model. And they were not just IT experts, but also linguists or lawyers, because the legal status of what we are developing and the data that we are taking to develop the model is also very important. It was funded by the Ministry of Digital Affairs. The first part cost the Polish taxpayer 14.5 million PLN, and the second part 19 million. So that's what the project was about. The first part, the PLLuM part, was about development of the model. The second part was more about deployment of the model in the public administration. But PLLuM is, of course, the name of the family of the models. So it's not just one large language model, but a family of models featuring various model sizes from 4 billion parameters to 70 billion parameters. They are mainly built on open weight models such as Llama, Gemma, or Mistral, but there are also models trained from scratch, just to compare whether they are good enough for certain uses. There are several versions of the models. So the base model, as you probably know, is just for modeling language competence. It can generate text, but it can't be really used for anything useful. So to make it useful, you need the second stage. You need to fine-tune the model with a series of instructions to make it follow specific directives, so it can then perform tasks such as summarize this or translate that. So the model is optimized to understand the intent of the task and act as useful command following tool rather than just a text completer. And the third variant of the model is a chat version. After alignment, these models are typically instructed, tuned models that have undergone further alignment training to behave in a reasonable way. And of course, there are different licenses attached to these models. So starting from fully open licenses, we developed the models that could be used commercially, but there are also models that are available under restricted licenses, which do not permit commercial use. So immediately, if you would like to, those of you who would like to use it immediately, there are two basic ways of using it. If you don't want to develop, you don't want to download your own model and try to use it as your own infrastructure, you can go to the URL that's given on the slide, and there is a chat window. It's running on the Clarin infrastructure because Wrocław University of Science and Technology, who is the leader of Clarin, the language resource infrastructure for science, social sciences and the humanities, had its cooperation with Wrocław Supercomputing Center, and that's why the first version was running there and still running at the Clarin infrastructure. There are two models you can choose from, and you can play and you can chat in a matter, in a way that's similar to ChatGPT. But of course, we shouldn't call PLLuM the Polish ChatGPT. People tend to use it and to say that because it was developed. It was funded by the Ministry of Digital Affairs, and it was developed to help the Polish government, both on the global and local level, with their administrative task, and to help citizens through public administration. So the second way of using PLLuM and testing PLLuM is logging into mObywatel. There's an app that 11 million of Poles is using nowadays, and you can use the virtual assistant there to talk to PLLuM about each issues such as, well, how to renew my passport or where to register my newborn child and certain matters. So with the chat window at the Clarin infrastructure, you can probably ask them to write a poem or do something that you could probably ask ChatGPT for. But in mObywatel, it will refuse writing poems. It will just answer questions related to administrative tasks. What's so special about the Polish large language model? Because people might ask questions, why is it important to have a Polish model? Is it reasonable to spend these millions of PLN to develop something while we have ChatGPT or some other models? There are tons of them published every week. Now, which goals did we have in mind when developing PLLuM? So there are some of them. First of all, we believe, and it was proven, that we can adapt this model much better to the Polish context, Polish culture, Polish language than what we can find out there in the world. Of course, there is always this official context, so we can adapt it to the administrative task of the Polish government. That's another story. And we can adapt it to the tasks that the administration is performing or the citizens would like to perform with the model. So we are not competing with ChatGPT or Google or to have a general use model for everything, but we develop a smaller solution that we use in the Polish context. So there's more to these three ideas. I think for a country, it's not just a project, but it is a strategic necessity to have an AI-based solution and to have some operational control over it and to build the ecosystem even to teach the people how to build and use the model, because it really, we all believe that AI can contribute to the Polish GPT and GDP. So it's really important for the state, I would say. I hope you agree with me. So how do you do it? How do you build your own large language model if you want to do it? First of all, you need vast quantities of data and you need to acquire them. It's not always easy. Of course, there are lots of data sets and corpora out there, but maybe you need to crawl some websites or contact people who own this data. We need to validate the data. There are lots of data that were OCR'd and they can't be used just like that, because then you have errors in your output. So you need to do some selection, you need to do some deduplication, cleaning the data, and it all takes time, but the data is at the very beginning of the whole process. Then you do the pre-training. You either train the model from scratch based on your data, or you just take one of the models that's available and you do the continuation of the pre-training with the data that you collected. So you already have some foundational model, and then you apply your data to make it a little bit better. Then there is a phase of supervised fine-tuning, then where you just feed the model with instructions. Instructions are just prompts and answers when you teach the model how to perform certain tasks and provide solutions to your problems. And there is this phase of alignment when you feed the model again with a newer bunch of data, with preferences, via rankings and ratings of outputs from a tuned model, which helps you to create a model that behaves the way you would like it to behave. So sometimes it means improving security at the expense of usability, but that's the price you're probably going to pay, so that your model doesn't curse or doesn't create the content you wouldn't like to see in output. So it's data at every step. It's not just the data that we use to train the model, because the training data is the most important. And in PLLuM, that's really great that we don't just have Polish or English data, but we also have the data coming from Slavic languages, data in Baltic languages. They were contributed mainly by the Institute of Slavic Studies. That was their role mainly. But we also have data in these subsequent phases. So we have these instructions, we have preferences. We also need to collect this data, and we should be aware that it is really needed for these two steps of fine-tuning and alignment. But it's even more than that. So when you think about building your own model, you just don't get the data and press the button and that's it, but you need to know whether it's good enough for your task. When you have to know that maybe it should be a part of a bigger ecosystem, because when you log into ChatGPT, you don't know what's behind the scene. Is it just one model, or there are a couple of models that do some, for example, output filtration? When the model generates the content, maybe you need to check additionally whether this content is good enough for your user. It doesn't contain some content that's prohibited, or I don't know, adult contents, or things that you don't want to see, and probably the model saw it in the data somewhere. So there is more data and more components needed for building the model to detect unwanted content or evaluate things, because when you create a model, you need to know it. It's good enough. It's better than the one that you created before. So there's lots of things you need to take into consideration when you build your own solution, not just pressing the button. So that's the proper table of contents for today's talk. We are maybe not in the middle, but I already said a few things, but I'm starting the table of contents now. I called it the 6 pillars of PLLuM. There are 6 principles which we use to build the model, and I organized the talk in a way that will be going from one to another, just to show you different aspects of PLLuM. So legal compliance, methodological rigor, safety, organic nature, user-oriented approach, and openness. Let's start with being completely legal. So it refers to compliance with Polish European law, and that's what we started with, because we started with verifying what cannot be done as far as training the models is concerned, because we all know that in September 24, the law changed because many companies developing the models started showing the content that it shouldn't be there. There were pictures showing copyrighted content that was supposed to be generated, but it, probably you remember, contained watermarks of some press agencies that were then suing the companies developing the model. So we didn't want it, because we are the state-funded project, so we need to be 100% sure that everything is safe and legal here. We wanted to check what cannot be collected, what's the permitted use in the field of text and data mining, because this was the expression that was stated in the law that was changed in September 24. So there are two most important regulations in this law. It's quite common sense that you can reproduce disseminated works for the purpose of TDM, text and data mining, provided that the right holder has not objected to it. That's clear. And the second point is that for scientific purposes you can do anything, and that's probably what we all the scientists understand that what we can do. But of course you can't publish the data set that you collected for scientific purposes only. This resulted in having two paths of creating the data sets for the model. So there were actually two data sets resulting from these regulations. So for training scientific models that will be made available non-commercially, you can collect as many data as you can, and it's still okay. So this data set contains finally 175 billion tokens, including some data from Ukrainian, Russian, Lithuanian, Belarusian, of course, smaller amounts of these data. But for training fully open models, the dataset was much smaller. It amounted only to 28 billion tokens. The number of tokens were counted with another large language model, that's Mistral Nemo. So what did we do to acquire this data? Because 175 billion tokens is a large bunch of data. There were many ways of doing, and many data sets that we could use. So first of all, the first box tells you about the data obtained under license agreement, paid and free data. So we really wanted to be serious about that, and we approached publishing companies to ask them for permission to use their data, and some of them agreed. We also were buying some data. Why buy data when there's so much data out there? Because you can get better quality. For example, when you crawl some newspaper website, you will get lots of ads, a lot of content that's generated by the content management system. And when you approach them, you can get this data as raw text without all this garbage you don't want to have to filter. So two datasets were bought in Hive, one from the Polish press agency, about 2,000 texts, and another one from Rzeczpospolita newspaper, 100,000 texts. Yes, I think it was a great investment, because it's much better data than what we can just get out there. Of course, the dataset also contains some public domain data, some legal documents, parliamentary transcripts. I'm collecting parliamentary data myself, so our institute also contributed to this part. There were also texts gathered from the web that didn't have this TDM objection without this restriction. And of course, we also contributed some data that were already collected during the previous years by consortium members. We, as the Institute of Computer Science, we are not just information technology people, but we are also linguists. So we were collecting language corpora with many useful data sets that could be used in the project. There were two large data sets that are also mentioned here. So common corpus, there you may remember that OpenAI once said that you can't really build a model with just open data. And there was a French startup that did exactly like that. And they even published a new version of this corpus in February this year. So the company, the startup, is called Playas, and we took their corpus to include in our PLLuM data set. And we also used Common Crawl, but you don't know what's in Common Crawl, so it's a different color, and it goes to the large data set that may be used only for scientific purposes under restricted license. You can't really do anything commercial with it because you cannot be sure what's in this set. So that's after doing cleaning, filtering, the duplication. I will tell you a bit more about that in a minute. We obtained these two data sets. So a very important part of our work was talking to these publishers, to data providers, to sign data agreements with them, because we just didn't want to create a model. We also wanted to contribute to the creation of good practices and standards of how it should be done, because state funds it, states needs to have control over that. So it must be really legal. That's what we did in PLLuM. So we had a data acquisition team with data stewards, with people calling the publishers, asking to sign the license agreements with them. And the statistics are not particularly impressive because there are lots of contacts initiated, 1,500 contacts, but they resulted in 150 negotiation processes. There were meetings, conversations. I even attended some of them. But only 25 contracts were signed. People are really afraid, and the problems they are trying to express are the following. They want money for data. It wasn't really nice because at the moment when we were doing it, companies started paying for data. So they were signing agreement with publishing houses that they will get something for that. So the climate wasn't particularly good for that. They had doubts. They were asking about what happens with our data, whether they use just for this model or new models in the future. There are so many institutions in the consortium. The data will just go public, and we don't want it because we earn money based on that. The regulations were changing. People were not responding. But there were also good examples of companies saying that, yes, we want you to take our data because we are doing something, and we want it. If you develop a model and people start asking questions about something, then we want the model to answer, oh, this company can do that. So it will be our company. We can be just the only company doing that, because that's what model will know. So there were also good examples of cooperation, but that's probably a bit sad that just 25 contracts were signed. Some of them were bigger publishing houses. Another pillar of PLLuM that's also really important is to be scientifically safe, not just legally safe, but to do it with some methodology, follow what people are doing when they are developing the model. That's why we conducted the work according to strict scientific standards. And it was done at all stages of the creation of the model, following world-class standards, also in connection with what was happening in the world of AI. So the people developing PLLuM were also reading papers, learning new things, and trying to apply this in the work. So a part of this process, because as you could see, we just took some models that were already out there and then did the continuation of pre-training. But we also did an experiment with a model built from scratch, from random weights. And that's something that's not done currently nowadays, because there is this idea that to build a model from scratch, you need to have more than 1 trillion of tokens. And that's what we didn't have. But when you have 100 billion, that's even less than we had, you can do the domain adaptation, language adaptation. That works quite well. But we wanted to do such experiment and see whether we can develop such model. And that's what we did. We trained 2 models from random weights, 7 billion and 24 billion parameters, but also, well, lots of other models. So that's what we managed to do. So I'm trying to explain the other part. So let's start with that. But it was just about being methodologically safe. So we did all these experiments. We had benchmarks and leaderboards. But with the experiment, we with the random weights, we just used the infrastructure of Cyfronet, this supercomputer Helios that was busy for 3 weeks, and 256 cards were burning money to see whether we can do something useful with it. So there is a 24 billion model as a result of this process, but we were checking it even yesterday, and it's not particularly impressive. It's much worse than what you can get when using Llama or Gemma or Mistral for continued pre-training. So there was another experiment. We also contacted Mistral AI to check whether their expertise and their additional data could help us to create a model that's much better than what we can do. And yes, and it resulted in a smaller model that could be run on an affordable computer with just GPUs. That's quite economical, and you can it's already available. You can use it and try to test it yourself. What's more to this methodological rigor is that it's not just creating the model, but evaluation of the model. So we created a couple of benchmarks for that to know that the model we developed is better than its previous version, or maybe another variant of set of hyperparameters works better than before. So when you develop lots of models, you could see that we developed more than 100 of them. You need to have the way of evaluating them. And it's not always the case that one model is best for every task. So we had like 7 or even more benchmarks that we used to check whether the model can speak better Polish than other models, or can refrain from generating hate speech, or can help with issues related to mental health. So there were many ways of testing the model, these various aspects of the model that we created. But of course, we also would like to see which model is best in general. So we created a leaderboard with a series of tasks that were rated, and that's what we can see in this leaderboard. We have, unfortunately, some text in Polish here, but we can compare the models of different types with various criteria, starting from safety and how good the Polish produced by the model is. It's quite good for all of them. How useful it is, how consistent it is. So we had this leaderboard in its methodology as well. And how did we evaluate the models? Because it's when you have 100 models and they are produced every day, it's difficult to evaluate them manually. So we use the methodology of LLM as a judge. That's maybe controversial because one LLM is rating another one, but that's how it's done. So we used DeepSeek version 3, which we selected because it's really stable for assessments and quality, and it was used as a judge, comparing the answer of the model with the model answer created by humans. And there was also one benchmark to rule them all. It was probably even developed before we started PLLuM, so might be a little bit more reliable than what we develop ourselves. It's been created by the National Information Processing Institute, and it's called Polish Linguistic and Cultural Competency Benchmark, PLCC, with this great chart of colorful categories. It tests the model, asking it questions about Polish language and Polish culture. There are 6 main categories related to history, geography, Polish culture, art, entertainment, grammar, and vocabulary. And the answers are graded in a rules-based manner. So you have various condition types, whether the answer includes some words or phrases that you require the answer to be correct, or probably doesn't. It excludes some phrases, and there are also tasks to order things and match some regular expressions. So it's very very useful, I would say. So some questions of PLCC are the following. I guess it really relates to the Polish culture, whether you know about this meme with this monkey. What is the species of the monkey that is used in this meme? And if the model answer is Nasalis larvatus, then it's good, it understands Polish culture. Because there are like 600 of such questions. They are not publicly available because for a benchmark it's not good when you publish your benchmark, because then the models can use it and adapt to it. But some questions are, and I just wanted you to know what's in there. So there is a question to the audience now, because I just selected 4 questions and I have another one here. What were the names of the 3 Polish mathematicians who managed to decipher the German Enigma coding machine? So anyone from the audience knows the name? Are you better than large language model? Probably yes. Everyone knows the names, right? Okay. Rejewski, Różycki, Zegarski, that's probably what you should know. Okay, so there are such questions in the benchmark. Just for fun, let's look at what the models, the commercial models are doing with this benchmark and how good they are. So the top of the leaderboard, which I made a screenshot yesterday, shows that Google beats everyone and knows a lot about Polish language and culture. Just to show you. There's one PLLuM model that goes a little bit below Google and Grok. Okay, another aspect of creating the model is its organic nature, which means that we don't just want to reuse synthetic data that's out there, or synthetic or just models that evaluate and create data for the models, but we really want to have some new data created by humans because it's much safer and much reliable. So we know that looking at this benchmark, we can realize that it's important to use the data that's created by humans, and that's what we did in contrast to synthetic data. Why is it important? This would be quite a quick and easy way to create a model just by feeding it with synthetic data extracted from the models that are already out there. But there was this article in Nature saying that the models really collapse when they are trained on generated data. So when you just feed the model with synthetic data, it just doesn't work. The quality is much worse. Apart from all the facts, all the other risks that you can see here, so there are some legal licensing risks. You don't know what's really inside the model when you use this generated data, and you lose control over it. And there are some examples of just with Polish calcs and linguistic errors that you could get when you ask the model. You don't say bardziej często in Polish, and you just when you generate the data by some other model, you are getting such words that I probably don't even understand what it can mean. This is cyberbullying. This is a generated name of a country that has a different real name. So that's Republika Środkowej Afryki. And if you use synthetic data, you really need to have control over what's generated, what you do with this data. And when you do it just to have vast quantities of data, so you can't really look with your own eyes whether it's good or not. So if you just take it and feed the model with it, you will get unexpected really replies at some point. So that's why we created our own human author instruction corpus that contained mostly organic data, which is the name we use for the data created by human annotators. 80,000 of such data created of different types and different tasks that are involved in it. We also used converted data, and converted data are coming from the existing resources that we owned as a consortium. There is a smaller number because we decided that we will just, the data are quite repetitive, so we will just use 1,000 instructions from each data set so that the model doesn't get confused with the larger number. And there are also synthetic data that are created under strict supervision of humans. So they are generated, but they are manually reviewed. And when you have just 100,000 of such pairs, then you can probably even look at it with your own eyes and still be safe about what's there. So in this PLLumic corpus, so the PLLuM instruction corpus, there are lots of types of data. They are not really balanced. You can see the generative instructions are probably represented the most. So there's 1,000 instructions of 12 types and 126 types. So generation instructions refer to generating mails, poems, or horoscopes. You can see all these subtypes here. So that's what we need to teach our model. As far as converted data is concerned, because that's something I just added this slide because we used lots of our data created at the Institute or gathered at the Institute of Computer Science at some point. As I told you, that we are just using smaller sample of this data, but there were like 30 or 40 such data sets included because the data sets correspond to some tasks that we would like the model to perform. So I'm just advertising my two data sets that were created long time ago, well, 10 years ago, it's a long time ago. In some other projects, we had money to create Polish summaries corpus, so people were creating the summaries of the size of 5, 10, or 20% of the original text, and they were abstractive and extractive, and this data set is used in many projects nowadays, and is also used as a source for instructions for our large language model. There is also a co-reference corpus that I created in one of my National Science Center projects, so it was also included here. So, I don't know, some pictures are missing, but sorry for that. So as far as the alignment is concerned, so the third phase of creating the model, we did the same. So it's also organic because we created preferences. So there is a prompt and preferred and rejected response, and people were rating evaluating which response is better, and we could use it to, I don't know why it happened. So now the secret of missing images is solved. So there is a prompt and preferred and rejected response with respect to certain criteria. So people were evaluating the language, whether formatting is correct, and that's how we created a set of preferences that were then used to align the model. There was an application for that developed, so there was a whole ecosystem of things related to training and building the model. It resulted in a paper. That's just an excerpt for the paper. In this process, we created more than 4,000 pairs of chosen and rejected responses used for aligning Polish or multilingual LLMs, and we published a paper about that, so it's open to take. And there were many, as you can see, feedback types and rating criteria, so it's really it's really useful. The preferences are usually used or frequently used to make the model safer, so that it responds in a way that you would like it to respond. So let's go to safety now. So safety intends to prevent models from generating harmful and toxic content, and that's what we also did, which resulted in one thing that you could probably expect when you in the picture at the top you have several systems that are compared. The instruct fine-tuned systems are compared to chat systems after alignment, and you can see that attack success rate, so how susceptible the system is to attacks, is much higher before we align the system, but the false rejection rate, so when the system doesn't want to answer, says that it can't answer because the prompt is toxic or in a way inappropriate, it's raising here after alignment. But that's the price we are willing to pay, I guess, because we just don't want the system to be susceptible to attacks. I guess we can live with 5% of false rejections. How to make PLLuM safe? Not again, but constantly safe. That's what we also did. We are learning how to react to what users are doing. We are collecting what the chats with users, so that we can fine-tune the models and improve the models to lower the false rejection rate when the new models are built. So between 2024 and 2025, as you can see, the false rejection rate dropped significantly due to the new preferences we used after we collected the data from the conversations of users with the system. And one word about the openness, two last quick issues, openness and user-oriented approach. We see an openness as the way of sharing what we did with the community. So we are sharing not just the models, we are also sharing data sets, documentations, reports, research results to help improve the Polish AI community, so that the people can just take not just the model and use it, but also all the data that we created, that we are allowed to be made available, and that's what we are sharing. And we are sharing, well, when I say we are sharing, it's not actually us, but the ministry, because they have funded it, and they have their Hugging Face site when they published what we have given them. So when you go to cyfra.gov.pl, then you can find all the models that we made available, and there are also some collections of them and some papers also linked there, so you can probably just take a model and download. When you see the numbers, download numbers, they're just for 1 month or from the beginning of the month. So, but we know that there were like a couple of hundreds of thousands of downloads of these models after we published them. So people are really looking at what we are doing. As far as scientific publications, it's also part of our openness. One of these publications was already published at EMLP, that's a major NLP conference in 2025. Two of them are still waiting to get accepted, but they are available on archive. There is a main paper that's called PLLuM, a family of Polish large language models, that has lots of authors and 83 pages where we document everything. There's also a report that has 350 pages, but I guess it's not publicly available. And there is a paper also available on archive about the PLLuM instruction corpus, the one that I was showing in a moment. When you go to Clarin website, you could also click and see the prompt book. So there are like 70 different prompt examples, the ways of how you can interact with the model to perform the task that you would like it to perform. We also think that it's really important to teach the user how to use the model, because sometimes people don't know it. Probably 2 years after we started the project, they already know how to use it, but in the beginning it was really, really important. And the user-oriented approach, a few comments on the intended use. As we know that our user is public administration, not just an average citizen, so it was adapted to the needs of the public administration. So it's part of the systems made available by the government, and I don't want to tell you too much about the deployment part, which was happening in 2025, because it's probably you're not the audience to listen about deployment, but just two slides about that. Apart from the typical administrative use, such as writing regulations, but also responses to mails, which is also made available by the system. One thing that was new to the model, and it's quite useful, is the language simplification task, because we have contacted the experts of Jasnopis. There's a company which I also was founding at some point, where experts were writing instructions dedicated particularly for language simplification. So you can already ask PLLuM to simplify, to write your text in plain language. That's quite useful, and people are really using it. And of course, we have the public sector case study of the system, so the deployment in mObywatel. It was a great success, I would say. There is this virtual assistant you can use. I was already showing the screenshot before. And it's based on the official content that was crawled or taken from gov.pl websites, and also tests and interactions with selected users from the public administration. So there was a moment when we asked people in the public administrations to test the system, to play with it, to try to break it, to try to ask it to perform certain tasks. So they have managed to have many conversations, and it resulted in a system that can really help you with official matters, find forms, create applications or mails that you can use to write to the public administration offices. So that's mostly it. If you would like to find out more, there is this PLLuM repository. I guess this link wasn't made public in one of the previous slides, so it's cyfra.gov.pl, where you can find all the models and data sets. And there is a chat window, and for mObywatel, you just need to log into the application. Thank you very much.
Thank you. Thank you, Professor Ogrodniczuk, for very nice, interesting lecture. And now this lecture is open for discussion. So maybe I will first. What is the relation between PLLuM and you mentioned Jasnopis?
Yeah, so PLLuM, the consortium, contacted Jasnopis. There's a company to ask the experts of Jasnopis to create instructions for fine-tuning the model that could simplify text, because Jasnopis was an application that was just intended to measure readability of text. It now has a component for text simplification, but it just sends the data to ChatGPT, so it's nothing very serious. But if we wanted to have something adjusted to our context and typically Polish, and not send the data to overseas, then yes, that's the way to do it. So we have the model, and we have some instructions that could be used to perform text simplification tasks.
Okay. Halucynacje. it is typical for such language models the word hallucinacja. So you can comment what about PLLuM and this what the word means, hallucinacja.
Yes, well, they can always happen. I guess the best way to prevent them is what was done in mObywatel. So the system is really strict about replying to just to administrative questions, and it refuses. I tried to, because when it was made publicly, I also logged in myself to check whether it can hallucinate or whether it can solve difficult things. And it was when I started asking too difficult questions, it just said, well, I can't answer this question, it's too difficult. And that's fair, I would say. So that's the way we should probably approach it. Of course, it's a RAG-based solution, so that's why it works like that. So maybe that's the answer. I don't know, Bartek, can you say something about hallucinations? We have an expert here. He's a PhD student, Bartek Żuk, who was involved in training the models himself. So I really want to advertise him. I don't know whether you can comment anything, say anything more serious about that.
I don't know if there's a lot to comment. Like, as you said, the system in mObywatel was a RAG, so the model gets a context on which to generate the response, and given that context, it usually hallucinates less. We did try to measure hallucinations, which is a problem of itself, especially if you have like hundreds or thousands of instructions to look for. And we did target some preferences and instructions specifically to like prevent hallucinations. So basically to teach the model to answer that it does not know the answer, if it shouldn't know the answer. So especially we did some like questions, some ridiculous questions like how many arms does the sun have? Because models like to basically make up the answers, and it also can ruin the further conversations, because once the model answers such questions, usually the following responses are also nonsensical, because it gets lost in basically in a space that it wasn't trained on. Yeah, so we did do that stuff, but it's an unsolved problem that I don't know if anyone has a truly real solution for. You just fight with it.
It's probably, when you take the base model, it will hallucinate much more than the models that are more advanced.
Yeah, it's one of the goal of the alignment process and the instruction fine-tuning process, but you just try to make instructions that teach the model to prevent hallucinations, but there are no real solutions for it. No. Yeah, I don't know.
Thank you. The next question, comments. Yes, Professor Janusz.
Maciej, congratulations for a great talk and great, sort of the big successes of Polish science, I think. But I have such a strange question. So which type of documents do you take into account? Why? Because I was at a meeting some maybe last month, and there was a very strange situation, because at the end of the meeting, they produced an official, summary of the meeting. Let's say in good Polish language and so on and so on. But I saw also the, let's say, point of departure for this official, and this was, people were doing like this. They were saying something, at the meeting, but they used WhatsApp with this option that you press, the button, and you speak to your phone, and it produces text. And these texts were completely different than the official, let's say, documents. So do you take into account both the official documents and say unofficial, let's say, like this one, preliminary text?
Yeah, so, I guess that, again, to make it completely safe, the RAG solution is the only way to do it. When you really want to get the answer for a specific question that's already there in the documents. But as far as the ACR is concerned, so I guess that's another story. So I don't know. Yes, maybe you can also have some ideas.
Well, like currently there is also like tool use, so the models can use a browser to search the internet and that way insert some documents in its context. we did experiment with it at the end of the Hive, so the second year, but I don't know if there is a version of PLLuM that uses tools. But
I think no.
modern models,
Gemini,
yeah,
yes, they can do it.
They probably use a browser to search for some information to prevent such things. Yeah.
Mm-hmm. But when you but when you just ask the system to do ASR, right? So speech recognition, then it should just just listen to what you say and not invent things. But it's sometimes difficult to say, because we were using LLMs for correcting text for the Polish stenographic transcripts in the parliament, for example. I was doing it myself, and sometimes it was really unpredictable. So it corrected that, I just wanted it to correct some typos, and it just changed the name of the speaker. And it was really funny, because one person from it changed to another person from the same party, so it had some sense, but it was not the person who was speaking. So yes, such unpredictable things can happen. So I guess that's one of the challenges to try to prevent the systems from doing that, and to try to be completely safe about that, because it can really hallucinate and can generate. That's probably the nature of this generative model, that it generates things. So sometimes generation means hallucination, but.
The next comments or question, yes, please.
One question: did you thought about using this new type of LLM from Pathway, Kosowski, Adrian, Dragon Hatchling is the name, and it is the new construction, and is very similar to human brain, and it have quite a lot of potential, but you have to train it from the beginning, from the basis, so it could cost a lot, I think.
Yeah, so you could see that it's really costly. So no, we didn't, and I guess the answer is that, it was relatively small project. So the first phase was running for 11 months, and we did all of this in 2024 practically. In 2025 was more about the deployment, less about research, so we didn't have much time to do that, but we did some experiments with reasoning and other things. I don't know, do you know this paradigm of training the model? But
I think I heard about it. It's inspired by neurology more.
Yes,
right?
yes.
But no, we only experiment with the classic architecture. I think all of these new architectures are tested on small scale right now, and just the basic language modeling task, nothing more. So it's not, I think, production ready.
Yes, it should have quite a lot of useful things. So you could know where in which neuron is responsible for what. Not it is a sparse activation, so it is only activating in the topic which is thought about. So there is quite a lot of useful stuff, and it can run on GPU. It's optimized for GPU, so it can be used on normal things. I think it is very interesting. Okay, so
Yeah, I agree.
and about data, everyone said that you have to use all data scraped from the internet. So Elon Musk, Anthropic, everyone, OpenAI using stolen data. So maybe it is the way to go. So every kind of data which is used by people are for people. So if we have to be on some kind of good, if we want to achieve something comparable to those big companies,
yeah.
Frontier Labs, we should maybe try this too.
No. So it's recorded. So I'm talking about legal compliance, and it's funded by the ministry. So no, we are not stealing the data.
Okay, thank you.
Okay. Any question or comments? Once again, please.
So I have such a question now. Suppose that you want to develop your model even further, let's say. So let's say what would be the best direction of further progress, let's say, to hire more people like you, let's say computer linguists, or let's say traditional linguists, or hardware guys, or software guys, or maybe architecture guys, or whatever. What is the most important thing for the further development of a model?
Yes, well, there was this famous saying that someone said, yes, at the project, that when I fire a linguist, the productivity goes up. So I wouldn't count on linguists, but rather on IT people like Bartek, who is really good at yes, technical things. So, but he also understands the linguistic part. So.
I think right now it's just more compute, not even like IT guys or hardware guys, just more GPUs and more data.
Yes, but scientists are really needed for this task. So you really need to be in touch with what's happening in the world. So read papers and try to catch up with what all the big players are doing. So I was also attending the Congress for Society that was organized in summer, and Tomek Czajka said that yes, we can't compete with the big players because we are too small for that, even as a country. But we can build smaller models, we can build domain models, and we can be better at these applications. So maybe that's the way for us to do it. We can invent new architecture. So yes, we need to be cleverer rather than richer in terms of cards and money spent. Because, well, that's why we can't do all the experiments we are thinking about. We have a certain amount of money to pay for the power to train these models. So if you need the power for 3 weeks to run the system constantly, to train the model, just to play with it, then you need to think about, well, it's a state money, or if it's private money, that's the same story, because it's also important. So yes, well, that's the way to do it.
Okay. So I see we don't have any question or comment, so I would like to thank you once again for a very nice presentation and very interesting. Thank you. Thank you.
Dziękuję, panie profesorze.
The seminar is closed. Thank you.